Hello, welcome back. Let's implement the functions. So let's see, these are the functions we need to implement. I'm going to copy this first one, the init function, and then I'll come to our .c file over here, and then I'll paste it, and then we can begin implementation. But to do that, I'm going to create a number of symbolic names first. I'm going to create some symbolic names to hold certain values. I'll come up here. I'm going to define the number of GPIO pins we have. We have 16 pins, so I'm going to say define GPIO underscore num over here, and this equals 16. Also, I'm going to define mode 0. I'll say define, and then I'll come over here, GPIO underscore mode register mode 0, and this will be equal to 0x3u, and then shift to position 0. Okay, and then I'm going to say define, sorry about that, I'm going to say define GPIO mode. This will help us during our initialization, and I'm going to say this equals simply 0x03, and I'm going to do a similar one for pull up, pull down. GPIO underscore pull up, pull down register, pull up, pull down register 0. Right, and this is the same, 0x should be this, copy, paste over here. Right, so once this is done, let's implement our GPIO init. I'm going to create some local variables here, uint 32 underscore t. I'll call this position, and then I'll have uint 32 underscore t. I'll call this temp. It's a temp variable we shall use. Right, and I'm going to loop through the pins. I'm going to create a for loop here. I'll say for position equals 0, and position is less than the total number of pins. I'll call this number over here. Position plus plus. In fact, I'm going to include 2 more local variables here. I'll say uint 32 underscore t. I'll call this one IO position, and I'll initialize this to 0 as well. And the next one, I'll call it IO current. IO current, and this initialized to 0 as well. Right, so what I'm gonna do is get the IO position. When I come into our loop, the first thing will be to get the IO position. I'm gonna do IO position equals 0x01 shift position. Like this, and then I'm going to get the current IO position by doing IO current equals GPIO underscore init, then the pin or typecast this to uint32, and then perform an AND operation with the IO position like this. Right, I've got a semicolon here. Okay, so once this is done, I'm gonna say if IO current equals IO position. If this is the case, then we start off by saying temp equals GPIO X mode register, and then we disable the pin first by using the bit disable. We do bit disable by doing temp end and then equals the tilde sign over here, GPIO underscore mode register shift position multiplied by 2 like this. And then once we've disabled it, we can enable it using the AND operator or the OR sign, using the OR operator I should say. This is the vertical line like this, and then we say GPIO underscore init mode like this, and then GPIO underscore mode. This we shift position multiplied by 2 like this. Right, once that is done, we can put the temp into the mode register by simply doing GPIO X. We're dealing with this mode register equals temp. Right, once this is done, we can set a pull up pull down register. We start off by saying temp equals GPIO X pull up pull down register, and then we say temp. We start off by disabling like we did before, like this, GPIO underscore pull up pull down register underscore pull up pull down R0, and then position multiplied by 2 like we have over here. Once that is done, we enable by doing temp equals GPIO init pull, then we shift this and we say position multiplied by 2, and then once that is done, GPIO pull up pull down equals temp like this. Right, so this will initialize our GPIO pin for us. Moving on, we're currently working with just these. We're not making use of the speed and the alternate function. Okay, so this would initialize the pin. Next, we can sort of write a function to read the pin. Let's go and copy the header of that function. This is it. It returns the pin state. I'll copy this, paste this over here, and I'm gonna create a local variable here. First I need to delete the semicolon, and then I'm gonna create a local variable here. Call this bit status. And then I'm gonna say if GPIO, we've got to find the pin first, so do GPIO X input data register and GPIO underscore pin if this is not equal to GPIO underscore pin underscore reset. I'm gonna typecast this. uint 32 underscore t. If it's not equal to reset, then it is set. So I can simply say over here should be not equal to exclamation sign. I can simply say bit status equals GPIO underscore pin set. Okay, and then we can simply use an else statement here. Else bit status equals GPIO pin reset over here, and we can return bit status. Copy this, return it like this. Right. Next, we've got to write the function to help us write to the pin, whether we want to set the pin high or low. We need to write a function to aid us. I'm going to come over here to copy the header. This is the function we're going to implement. I'll copy this, come to our C file over here, paste it over here, open and close. And I'm going to use the BSRR register for this. I'm going to say if pin state is not equal to GPIO pin reset, then this should be not. I keep typing this. If it's not reset, then we're gonna say GPIO X BSRR register, the bit set reset register. Simply write the GPIO pin to it, GPIO underscore pin, and this will set it. The BSRR register is like the output data register. We use it to set and reset the pin. Then I'll say else over here. GPIO X BSRR register. I'm gonna shift it by 16, and I'll explain why that is required. We'll go to the reference manual and see, and then shift 16, and then I'll typecast this uint 32 underscore t. Okay, let's go and take a look at the bit set reset register. I'm gonna open the reference manual from here. Okay, so I think it should be down here. It's not here. I'll go up. Okay, I think I missed it. Screw this. Let's search this. I'll press Ctrl F and then I'll search BSRR. And then I'll click here to jump there. Okay, so we can read a bit about it. The BSRR is used to set and reset our GPIO pins. It's a 32-bit register. The first 15 bits are used for setting, and the first 16, I should say, because we count from 0. The first 16 bits are used for setting the pins, and the next 16 bits are used for resetting the pins. And whenever you hear reset, it means disable or to turn off. So that is why the first 16 bits are referred to as BS, 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 and the ones on top here, BR, BR, BR. So this, if I'm dealing with BA5 and I want to set BA5 on, if I want to set it high, I simply need to come to BS5 and write 1 over here to bit number 5. If I'm dealing with PA3 and I want to set a high, I can simply write 1 to this bit over here, just like I'll do in the output data register. But this same register, if I want to turn the bit off, if I write, let's say I'm still working with PA5 and I want to turn it off, I don't write 0 here. If I write 0 here, it wouldn't have any effect. To turn this off, to turn pin number 5 off, which is bit number 5 over here, I need to go to BR5 and write 1 to BR5. So BR5 is over here. I need to write 1 here to set bit number 5 to reset. To reset it, BR5. So in the same way, if I turn on with bit 1 for pin 1, I turn it off with bit number 17. So if I turn on pin 0 with bit 0 here, I turn it off with bit number 16. So that is why we're shifting 16 times over here. So we're saying if the pin state is reset, if it is off, let's see, if the pin state is not off, if it's not reset, then simply write it, because the pin number corresponds to the bit to turn it on. However, else, this else means however, if it is off, if the person decided, if the argument is to reset the pin, then we've got to shift 16 times and write 1 other position in the BSRR register. That is why. Okay, if you don't understand what I just explained, just send me a message. Right, so that is done. The next function, let's take a look at it. The next function, where is it? It's the toggle. This one here, I'll copy it and then come over here and then paste it. Open and close. And this, I'm going to use the output data register. I'll simply do GPIO X and then ODR, and then I'll use the toggle operator GPIO underscore pin, like this. Right, okay, so once this is done, we have our other functions. Let's see, these functions for enabling clock, we would implement them as well. I'm gonna copy this GPIO A clock enable. I'll copy this, come to the .c file over here, and I'm going to implement this. To implement this, we simply go to RCC, and then we know our GPIO is connected to AHP1 bus, so AHP1 enable register, and I'll simply write the symbolic names we created. This one here, we had symbolic names in our driver. Let's see down here. Okay, so this is a GPIO A enable. I'll copy this, and this is what I'll write here. Right, and this is going to enable GPIO A. So I'm actually going to keep all of this on a vertical line since it's a small implementation. I'll copy and paste this for the other ones. Okay, so this becomes B, C, D, E, and H. And then this becomes B, C, D, E, and H, like this. Okay, so we've implemented all of our functions for the library. Right, next thing, we test it out. So how about we do that in the next lesson? I'll see you in the next lesson.